Okay, so what we're going to do today is we are going to do something similar to what we did yesterday, but it's just a different take on it. And you can really do it either way. But first, in the class opener, let's review what we just did. And it's the geometry, I think, that's getting in the way. So there's your diagram. Put in dx, put in delta x, put in delta y, and dy. I'm going to walk around and check to see how you're doing. How are delta x and dx related? You're going to remember this diagram we had yesterday? This is delta x, right? And remember that f prime of x, the slope is of the tangent line. What's the slope of the tangent line? It's dy over dx. Think of that dy and dx as literally the delta y over delta x, but it's of the tangent line, not of the function. I'll just put an arrow there. So can you mark them on the diagram? That's the question. What is delta y? Okay, it's going to come on. There. Ooh. Where did my iPad go? Oh, I'm plugging it into. Yeah, that's right. Okay. What's true with delta x and dx? They're the same, because remember, dy over dx is the rise and run of the tangent line. So what's this segment? dy, do you have that? And this is geometry. So dy is just that little segment. What's this one? That's the change in y. That's the actual change in the function. So we need to fill in the spaces. Somebody want to come and fill them in? Did you fill them in yet? Delta x represents what? X on what? Basically, it's delta x is on the curve, right? Do you need a handout? Why is dx? Because dx is on the tangent line. So delta x represents the change in x on the curve or the function. Okay? What's delta y? Change in y on the what? On the curve. Look. Forget calculus for a moment. If this is one y value and this is the other y value, this distance represents the change in the y values, which is y2 minus y1. No calculus at all. That's all stuff you've done before. So delta y represents the change in y on the function. Okay, so that's the real change. That's not an approximation. It's the real deal. What about dy? Y on the tangent line. But you don't want to memorize it. I don't memorize it. I look at the picture. Too much. It's just too much stuff. It should make sense because then you remember. When something has meaning, you remember. If you memorize, it only stays for so long. I'm still pretty good with French, but I'm not nearly as good as I was in high school because I haven't used it, and that's memorizing. Okay. That's what we did yesterday. To find the y coordinate here, Mr. Dahman said his students had trouble finding that y coordinate. Okay, you guys? To find the y coordinate, you would take this y coordinate, f of a, If I wanted to find where this is in the coordinate plane, I need this length, right? See the rectangle here? I'm going to have this length, that's f of a, and then I would add this length, which is what? Plus the change in y. If I want an approximation to the y coordinate, anyway, you got room on that. If I want the approximation to this, approximately the y coordinate, I would still take f of a plus, but not the change in y, I would take the change along the tangent line. And that's what the homework was asking you to do. We can look at problems. This won't take very long today. Okay? Are we ready? So we're going to go on and we're going to do the next picture. Consider this function at the point x equals a. I want you to write the equation of the tangent line. So what's the ordered pair at a? Remember, it's f of x. So this is a what? F of a. Not very well easy to read, but what is the slope of the function at a? No. Nope, it's the slope of the tangent line. What's the slope of the tangent line? dy dx, but in terms of function notation, you can do this, dy dx out at x equals a. I don't want to put that in my formula. Why don't we write it as f prime of a? Write the equation of the tangent line. What line?
dy over dx.
That means at x equals a. That's the notation for that. Because somebody said I want dy dx. It's easier to say this. It's easier to use f prime of a, isn't it? Okay, what's the equation of the tangent line? You have it written down yet? You have the tangent line down? Write it down. I know how to write it. But you guys, can you write the equation of the tangent line? We always do point slope formula. No. Equation of tangent line. You have a point. Point slope. Do you remember point slope formula? If you work on this, you might. Yeah. That doesn't always work. No, I want the equation of a line. What's the equation of a line? We forgot this? Y minus y1 equals mx minus x1. So what's the equation of this line? You know it. We're not going to memorize this formula either. We're going to figure it out every time. So it's y minus what? What's the y value? F of a equals slope's right above here. It's highlighted. Yeah, it's just and this is just a number, right? Slope is only a number, but it's the derivative evaluated at a. It's 2. No. So this should be y minus f of a equals f prime of a x minus a. I don't want you to turn the page yet. Solve for y. Solve for y. What's y equal to? Y is equal to f of a plus f prime of a times x minus a. And that's what we mean by linearization. This tangent line approximates the curve as long as you're close to a. If you get too far away from a, what happens here? This is way wrong, isn't it? As long as I'm close, it's a very good approximation. It's how your calculators work. Your calculators do not have tables of values stored in there for the sine and cosine and tangent functions. They do the linearization. Actually, and it may just do linearization. In BC Calc, we add more terms. Because if I could approximate this curve with a quadratic, I think that would be even better. So let's say I tried to find a quadratic equation that fit there. That fits pretty darn good here, not too bad here. Certainly better than that. And what if I tried a cubic or a quartic or 5/5 degree or 100th degree and have a whole bunch of terms there? And that's how your calculators work. That's how computer science works. It's also in biomedical engineering. Students come back and talk to me about that. It's called an infinite series. It's called a Taylor polynomial. This is the very beginning. We're only going to do lines in this class. That's all we have to do. So instead of calling it y, they're going to call it L of x. So I don't memorize anything. I write the equation of the line and solve for y every time. And that gives me my approximation. It gives me what they call linearization. It's right here. It's the y value plus the derivative times x minus x minus a. I could have just given you the formula and you could just plug it in, but then that's memorizing. And there's so much you have to memorize, that's too much. It's just easier to write the equation of the tangent line that you do have to know. Yes, it's another way to do some of the homework, not all of it. Okay, linearization is nothing more than writing the equation of the tangent line and then solving for y. Now, here's the other, and you've had the questions on linearization before. You've had them in your tests. And Mrs. Hertzman says, they can't do that. We haven't taught it yet. I said, yes, they can. They can write the equation of the tangent line. They can do it. You don't even recognize. You didn't even know you were doing something you hadn't really studied. And you did it. You did it well. By the way, do not simplify your linearization. Leave it x minus a. Some of you want to make it y equals mx plus b. Don't. It's going to be much easier not to do it. Okay, so we're ready to try a problem. Okay, it's similar to what we did yesterday. It's just a different way of saying kind of the same thing. So I want to find the linearization for the square root of x at x equals 100. So first I'm going to graph this thing. Not to scale. Okay, so here's x equal to 100. And what I'm asking when they say this, it's find the equation of the tangent line. That's all it is. So I do the easy things first. What's the ordered pair? It's 100, comma, the square root of 100. So it's 100, comma, what? 10. And then we're going to use that linearization to find some estimates. So we need the equation of the tangent line. You guys remember how to do that, right? And I could use that formula, but I don't want to do it. Y minus y1 equals m x minus x1. So I have y minus 10 equals my slope, and it's x minus 100.
So in this problem, we don't know the slope.
You do. How do you find the slope? It's the derivative, right? M is equal to dy dx. And y is equal to x to the 1/2. Now we're not using differentials, we're using derivatives. If you really think about it, you can maybe make those connections. What's the derivative of that? One half x to the negative 1/2. Well, I don't like that. I don't like that negative exponent. 2, and that's the square root of x. Are we okay with that? Jason? So at 100, and so we write it this way, we're going to do this at x equals 100. What is that number? So m equals 1 over 2 times 10, or 1/20th. You can leave it 1/20th, or we can change it to a decimal. Kind of up to you. So what is the equation of the tangent line? I'm just going to write it here. Can we use it in a second? So y, and you can just do this right now and leave it this way. You don't even have to solve for y. We will. Is equal to 1/20th. And then it's x minus 100. Now, if I want to estimate the square root of 101, I'm going to use the tangent line. That's up here. Is that an overestimate or an underestimate? Here's the real one. This is the one on the tangent line. It's not exact, but it's pretty darn close. Is it bigger or smaller? It's bigger. So this is going to be an overestimate for this one. How about the square root of 99? We'll put that one over here. Nope, it's still what? Over. I just draw the pictures and then I know. So on the exam, they will ask you this question. Is it an overestimate or underestimate? I just look at the picture. So it's an overestimate. Oh. And I'll let you think about what has to be true to have an overestimate or an underestimate. I'll let you play with the graphs. I just draw the picture every time because I never can remember. Okay, so y equals 10 plus 1/20th x minus 100. And the reason I'm writing it in this form is it's the beginning of the Taylor polynomials. So if you take Calc 2 next year, BC Calc, you're already started on it. Trust me, they don't like it. So I'm just going to evaluate my function when x is 101. That's what I want to do. I want to find the y value on that line. So let's put in 101 right in here. So I'm going to get y equals 10 plus 1/20th of, whoops, that's supposed to be a 101. What's 101 minus 100? It's 1. Do you see why I don't want to distribute all that out and combine like terms? The arithmetic is much easier. So what's 10 plus 1/20th? You can write it 10 and 1/20th. Or you can write 10 point what? Anybody know what's the decimal? 0.5. Because that didn't change. What's 101 minus 100?
But isn't it 1 over 2 the square root of x? Now,
Yeah, but what's the square root of x? It's the square root of 100.
so we don't put 101 in there?
I put 101 right in here for x. That's my x coordinate. This is the slope. Yeah, no, I put in 100 because I don't know this. That's the reason why I'm doing it. I don't know the square root of 101. Well, I happen to have my calculator up, not my 83 or 84, but let's find out what the square root of a 101 is. This is a way to find that. So I have to go and I'm going to add a page. No. Let's find the square root of 101 and then we'll come back to it. We'll go back again. Square root of 101. Now what's going to happen here, because this is an Inspire calculator, this is going to give me the square root of 101 back again. It gives me the exact answer. So only way I can get back to decimals is I could set it so I go to decimals every time, but Control Enter will do it. It's 10.0499. Now I can get more decimal places. So the real answer here, let me write it in red, and then we'll go back and talk about your question again, is approximately equal to 1.0499. Oh, thank you. Let me erase that so it's not messy. I promise the erasers erase too much. That's the reason why I don't like to do it. This is on the calculator. Yeah, it's 10. That's what happens when I try to memorize. It gets worse when you get older. Okay, so understanding really helps. Let's look back here. I want the square root of 101. I want this value, x equals 101. But I am not going to find that value on the curve because that's what I'm trying to find when I use an estimate. I'm just going to use the tangent line. Where is my slope being found? Not at 101, it's at where? 100. That's the reason why I put 100 in here. I'm not doing the tangent line at 101, I'm doing the tangent line at 100. I'm not sure what you mean. I want to find this, the square root of 101. I'm going to evaluate, I'm going to substitute it into the tangent line, the linear equation. But where do I calculate my slope? Where did I calculate my slope? At 100. So that's what this is. We found an approximation to the value of the square root of 101 by traveling along the tangent line. So what if I want to do 99? Which I don't have a lot. Oh, there it is.
But you get a negative.
That's right. I get a negative number. Excellent. It's okay now. Oh, good. I was wondering if I could move these. It all depends on when I wrote these. So let's do the square root of 99. I'm going to use my formula, my tangent line. Why do I use 100 to get the slope? Because that's where the tangent line was created. So to do the square root of 99, then I'm going to put in for x what? 99. And you're right, I'm going to get a negative number because, whoops, 20th, 99 minus 100. And so that's going to give me 10 minus a 20th, or 10 minus 0.05, which would give me 9.95. And then we can find the error. So how, and now remember, a square root function goes really slowly, so that's the reason why it works out nicely. Let's find out the square root of 99. So I'm going to go control, square root, 99. I don't know if I can do this. I'm going to try it. Control, enter. Oh, no. 9.94987. What did I do wrong on my arithmetic? No, I did it right. 9.94987. Well, what do you think? Not bad, is it? Now, to find the error here, what do I have to do with these two numbers? I have to subtract them. Before I had the difference. This is not, I don't have the difference. I have to find it. So I'm going to cheat. I'm going to do this, what was it, 9.95? 9.95 minus, and then I'm going to go up and pick that number up. There's enter. Now I get all my decimals. Enter. And there it is. That's the error, 0.000126. Wow. Yes. You take the change in, you do the difference between y approximate minus y. Actually, I have to divide it yet. Exact. It doesn't matter. Absolute value of that and divide it by y exact. So I'm not done. That's just the difference between my estimations. So now I have to take that and divide it by. I haven't even gotten there. That's just the difference. This is my approximation. That's the actual one. So I have to divide by the actual one. So I'm going to hit divide it by, and I'm going to go back up and pick up that. And you always have to use all the decimal places when you do problems on the exam. So it's 0.4013, and then we'll change it to a percent. 0.000013, and to change it to a percent, you move this over twice, so it's 0.0013%. Now, if my iPad, the effective rate was that. That's okay. It's pretty darn small. That's how far off you are. Just based on the tangent line. That's why your calculators just use tangent lines, because it just number crunches. Just graphs the little tangent lines. I mean, they're really little. Your delta x isn't as small as 1. Your delta x is like 0.0001 when it does it. I don't know how they did the pixels, but it would have something to do with the pixels. So let's look at any questions you had. You said you had some troubles with last night's homework. Well, this is going to be fun. Well, when I do one of these problems, you can use either method on some of these problems. I like the tangent line. Sorry, I just can't even get in here. So, those of you who said you had problems with homework, those of you who didn't try homework, you need to do the related rate problems, because if you don't, you're going to be in trouble. I do believe it's going to be a free response question this year. So, the related rates, that's our next section, 4.6. But 4.5, some of you aren't doing the homework. What about 27 through 30? Did you understand those questions? Should we look at number 30? I don't know if it was assigned, but I like the question. Okay, this is 4.5. Number 30. And it has this weird looking notation. But if you read the directions, you'll know what it is. The reason I like this is because we're going to review a little bit here. And it says find the differential. So if this is y equal to 8 to the x plus x to the 8, they're asking for just dy. Well, what's dy dx? Now, do you remember the derivative of 8 to the x? Told you like to memorize this. It's a to the x times the natural log of the base, which is 8. That's an exponential. Do you remember those? E to the x is always e to the x. A to the x is always a to the x, but you have to do the log of the base. And now the next one's a power. See the difference between that? That's an exponential, that's a power. Powers are easy. 8x to the 7th. So the differential is, if I solve for dy, because that's what this is asking. And I can see why you might not know what to do because you didn't understand the question. But if you look at the solutions, you should be able to see that. It's just this. It's the derivative of this function times dx. That just means find the differential, not a, if they had wanted you to find the derivative, it would have looked like this. It's just the top part. It's taking the derivative and multiplying by dx. It's called a differential. When we get into integral calculus, we're going to be using differentials. So we're going to have to get that part. Okay, what else? 19 through 26, it says find dy and evaluate dy for the given dx's. Are there any questions on that one? I don't even know what was assigned. 19 through 26. (21 through 23). Why don't we do 23, because that looks hard. Y equals e to the sine of x. X equals pi. And dx is equal to negative 0.1. The mechanics of doing this is not particularly difficult, but I'm not sure you know what you're doing. I want to find dy, which represents the change on what? The change in y on the tangent line. So, is that all it asks? Right. So doing it isn't too bad. But what is it we're doing? So I kind of would like to see what that curve looks like. Anybody have an idea what it looks like? That's been a pretty much, well, no, I don't know what it looks like. So it's e to the sine of x. So I'm going to add a page. Okay, just do this. And if you want to do that with me, you can. I've got my calculators over there. They're all charged up. It is with an Inspire. Oh, I hit the wrong button. Add a page. There we go. Anybody want to use a calculator? Oh, the Inspire is kind of nice. Okay, we're going to add a graph. And down here is my entry line. I want to do e to the sine of x. So where's e? There it is. E. And then it goes up there for me. And then trig sine of x. So I press enter. And then I got to put an x in. I like it. It knows that we need another parentheses there. So it kind of reminds you. And if you forget, it's okay. And then we just press enter. That's kind of a cool graph. I've never seen that graph. And we want to do this at pi. So let's draw our tangent line at pi. So on the 84, you go to the draw menu and you draw the line. Here, I go to points and lines, 7, and I do a tangent line, 7. And it says where? Am I going to be able to do that? Okay, I want to do this at pi. Well, I'll be close enough. Pi is pretty close to 3. That's not too bad. Here, I'll make it extended. It doesn't give me the value of the slope, though. Is the slope positive or negative? It's going to be negative, right? Not at pi. Sorry. And then, by the way, if you want to change your axes, you just touch them. And I can do this. And you have, on the Inspires, you have a touchpad, so you have a mouse. And And I don't want this again, so I'm gonna press escape. Let's see if I can find the coordinates. Let's see, menu. Let's try actions, attributes. Okay, yeah, that's what I want. Oh, that's the only way I can change it. Okay. I'm not sure, but that's what I want to do. So I'm gonna take a picture. This takes a second. It takes longer than it does with the 84, unfortunately. And then I'm going to go down here, and I'm going to come back in here. I just like to see the picture. Okay, it's not exact, but it's close enough. So I want to find the equation of the tangent line. So what's dy dx? It's e to the what? Sine of x. Do you remember what not next? Times? No, close. The right idea. Derivative of that, cosine of x. So if you solve for dy, we can do this two ways. We can write the equation of the tangent line. Well, actually, they only want dy, though. Is equal to e to the sine of x times the cosine of x times dx. And where are we going to find this change? And why is, if dx is negative, that means I'm going to go to the left, 0.1. Sorry, it's not, obviously not exact. And then I'm going to go up to the tangent line. Well, based on my picture, is that an overestimate or underestimate? Under. Okay. And so dy is going to be equal to, we're going to evaluate the sine at where? Where did I write this? Where did I draw this line? At pi. So it's e to the sine of pi. I like to show my work. When you are taking the exam, if you mess up, and you have clearly demonstrated the intent of what you're going to do, you might get more points. Most likely you will. And dx is negative 0.1. Plus, you'll probably get the answer right. What is the sine of pi? 0. So this is e to the 0 times the cosine of pi. Do you remember what that one is? No? No? It's negative 1.
Oh, yeah.
And if you look at the picture here, you can see that the dy is going to be a positive number, isn't it? If delta x goes this way and you go up, then what's dy? Positive or negative? No, dy, the slope is negative, but what's dy? Positive. If you had gone down, then this dy would have been negative. So the answer is, this is 1. 2 negatives make a positive times 0.1. The answer is 0.1. Is that what the answer of the book says? Didn't ask for you the value of the function. Okay? That's all there is. Not helping me here. You need some time to work on these. Okay, if you want to graph, it might help you to graph some of these things. Whatever's on the assignment sheet. Yeah, the only one I changed was 4-4. Oh, do you want to do any more questions on 4-4? No, assignment sheet should be right on 4-5. It's just the order in which you do the problems. Do you want me to do any more out of 4-4? Did you guys try 4-4? Remember, one of those questions is on your test. 21. Okay, we're going to inscribe a rectangle. I'm going to need a graphing calculator again. Now, on my answer key, I talked about all the shifting. It's not my goal. My goal is to figure out how to do the problem. It says we're going to inscribe a rectangle under the arch of the curve y equals 4. Actually, we could do a quick sketch. At the point there. And x is equal to minus pi to pi. Is this cosine curve odd or even? It's even. Okay. Well, I know what it looks like without doing any work. What is the cosine? 4 times the cosine. Just what does this 4 do? It's the magnitude. Does this, right? I'm not sure exactly where that is, but we can figure that out. Okay? Maybe I better look at that. Let's look at that. I'm using this only because I have it up. Okay, add another page. We're going to add a graph. Now, the thing is, all of this is connected in one document. Everything I've got here. If I print it out, I get everything, even the stuff I was doing before. So let's say I was doing a science project and I wanted to have some statistics, some tables, and then maybe I wanted a graph, and then I wanted a discussion. It's all in one document. Because I could add a notes page. If I add a page, I can do notes. And I can type. I have to go to my keyboard here. So that's kind of cool. And you can go back and you can see. So notice it starts with F2. Because what's F1? I go here. No, I don't want that. Wait, I think I do this. There's F1. It's still there. It's assigned F1. See, it's bold. So I could use it later on in whatever I'm working on. Okay, but I don't want to do that. I want to graph 4, and I should be in radian mode, cosine of 0.5 x. And I want to graph from minus pi to pi. I'd like to find out where those zeros are. I could find the zeros. Okay, let's do it. Menu. I can analyze my graph, and I want the 0. Yeah, but this is so cool. You have to just put your cursor down someplace, and then there, and there it is. Oh, it's at pi. I wasn't going to guess that because it was so close there, but 3.14 is close. But isn't that cool? Analyze graph. To do my zeros, it's much easier than your 84. So I want to look at that 0, so I put it there, and there it is. Cool. Okay, so we can go back. So we know that now that this is at pi and minus pi. Now we just put our rectangle in there. This is like what we did yesterday. What do you want to call this length? X. Then this length is also X. And this length is pi. So what's the area of my rectangle? That's why I did that on the problem yesterday. Yeah, so the area is equal to 2x, y. My interval is from minus pi to pi. So I just have to evaluate that. Which one do you want to eliminate, x or y? I've got too many letters. I want to do y because, guess what? I know what y is. It's that. So area equals 2x cosine, oops, not cosine, there's a 4 there. 4 cosine of 0.5x. What does that give you? 8x cosine of 0.5x. And now I'd have to take the derivative. Like a cheat, because my calculator does it. Now, that's the problem with the exam, with the CAS. So let's say this were an exam question. If you used your CAS calculator to give you the derivative there, and it looks like you used the calculator and didn't really do it by hand, you won't get credit for it. Yeah, couldn't I graph it? And well, I don't know if I could graph it and figure it out. So it's what? It's 8, it's x times the derivative of the cosine. What's the derivative of this thing? Negative sine of 0.5x times 0.5.
Why did you use the
Product rule. This is x is not that x. It's the first one times the derivative of the second plus the second one, the cosine of 0.5x, times the derivative of the x. And what's the derivative of x? It's just what? No. I pulled the 8 out. I ignored it. I only did this piece. So it's 1. You have to use the product rule. Can't take that x inside the cosine. Wish I could, because then life would be a lot easier. I have to use the product rule. I don't have a choice. 8's still there. I could. I have an 8 here and an 8 there. It doesn't matter. I just don't want to bother with it. So because a prime is equal to 8 and it's negative x sine of x over 2, maybe you like that better. I don't know. Oh, times a half. Plus the cosine of 1/2 x, or x over 2. And I want this to be 0. What's going to make this a prime 0? Not the 8. It's going to be this piece, right? That's what I have to look for. I don't particularly care for it, and we have to find the zeros. It's graphing calculator problem. Can you guys do that on your own? Yes, no? No. But that's not done. So we have to find the zeros if there's more than one. I don't know. And then what are we going to do? Because I have a closed interval, we are going to do the max min existence theorem. Oh, there it is. Come on, slide. So we're going to evaluate the function at, now I do have my calculator up and running, which is nice. Why is this doing this? Do that. And then come back. So where are the endpoints? Oh, don't do this to me. Okay. Oh, I'm probably undoing a few things. Oh, wait. There we go. That's weird. Okay, so what we have? We have x and we have a. And we have, what? Negative pi and pi. So that would be if my, actually I don't have, the x is not, can't be negative pi y. Remember, x represents the distance from the origin. So, it can't be negative. So x has to be greater than or equal to 0, but x has to be less than or equal to pi. So my interval actually is 0 to pi. Because x can't represent that negative number. And then you could have a rectangle like this, where x is close to 0. So it's 0 and pi. What's the area when x is 0? Yep, that's 0. How about pi? It's this rectangle. So if x is equal to the endpoint, look at the picture. What's the area of that flat line? 0. If you put the cosine, if you put the pi in here, it's half of pi. So cosine of 90 degrees is 0. Okay, so then we have to figure out what that is. And do they ask us to evaluate it? I don't know. 21. It says what are the dimensions and what is the largest area. So do you want me to find the 0? Yep. Okay, I got to write this down. I can't shrink that graphing screen like I can on the 84. And I know I won't have that memorized to do that. I don't care about the 8. We can put the 8 in. But the 8 doesn't affect anything. So we want to graph this. So I'm going to add another page, add another graph, and notice I'm in F3. Oh, did I pick the wrong one? Sorry, graph is 2. No big deal. Even if you have an inspire, you want to negative x divided by 2. And then I have to do times. Oh, yeah, this should work. Sine of x over 2. I'll find out in a second. And it says you need 2 parentheses. You're right. Plus trig cosine. It doesn't hurt you to see this new calculator. And it's x over 2. Because you could be doing it on your 84. Anybody have an Inspire in here? You have an Inspire? Oh, okay, cool. And then I'm just going to press enter. There, I'm going to check it. Did I type it right? Yeah, there it is. Now I want the 0. So there are a couple ways to do it. Personally, I like this way. And I want 0, enter, and all I have to do is touch it. Do I want a negative number or a positive number? Positive, so I'll touch it there and there. There you go, 1.72. Now I'm going to do something to answer my own question. I'm going to add a calculator page. Because on your 84, if I type in x, it remembers where it was last. Oh, it's a cast. That's the problem. Anyway, it's 1.72. I'll have to figure out how to do that. So this is 1.72. And then I want to evaluate my area formula, this one, and find the area. Yes, it asks what's the largest area. So I'm going to evaluate it there. So I am going to, I want all the decimals, but I can't figure out how I'm going to do that. And so the area was 8x, right? 8 times 0.172. Actually, I'm going to do it a different way. I'm going to do 8x cosine, and it's half of x. And it won't do anything for me. It'll just be there. Okay, and I want to put 0.172. I'm going to store it in. Oh, yeah. No, it's 0.172. It has to be less than 5. Wasn't it? Okay, we'll find out. We're going to go back. What is it? 1.72. See how I do that? Just go back. It's nice. So now I can go back in here. Put my point in. Let me go delete this point. You don't have to do an insert. Press enter. And now I'm going to evaluate that. So I'm going to go up and grab it. Enter. It should evaluate it at that x value. Oh, I know what's wrong. When you do this, I actually have to put a time sign in there. I keep forgetting about that. I don't like that about this calculator. Now we can do it. 8.97754. It should be right. Did I forget it too? Oh. No, I took care of the 2 there. Yeah. So it's a calculator problem. Not too bad. Okay. Now there's only 3 minutes left. We'll be available on Tuesday. If anybody needs me after school tonight, just let me know. And there's only a few more left on 4.4. How about that worksheet? I should get the solutions are probably not online. Oh, no, wait, I think they are, but they're on a smart board, but I'll get them scanned and put online. That worksheet that we gave you with the practice AP problems, it was a white one. It says AP Calculus, AP Problem Section 4.1 through 4.3. This one. On number 4.
Okay.
Have you done number 4?
Yeah.
Okay. So I'll get answers up there, but was that bad to do? No. I'm sure it's right, but just because you have to make sure you're careful there. But yeah, it's not bad to do at all. Huh? On this one? No, on this I didn't. That was your quiz. It's similar to this. I don't remember looking at that. I thought I was half asleep. Actually, I think I was. Still haven't figured out how to use my navigator quite yet. I'm working on it. So this is not too bad an assignment. Let's see. If you've done number 4, do number 5. Add in number 5. This white shirt worksheet. We did 1, 4. Make sure you get it done and ask me questions. I'll get answers put up. So try number 5. The only way you get ready for the exam is to be working on AP problems throughout the year. Yes, it is. It is. It's multiple choice. You have all the AP exams. They are online. 97, 98, 2003, 2008 are online. I thought I stopped this. So you can go back and do them.